Alright, the last video seemed to have cut off kind of abruptly. It's because I had modeled a good ways into this and then realized the technique I was using wasn't going to work. So I just cut that part out of the video entirely, and I'm going to continue from here. So I have these 6 faces that I want to make insets out of. So the way I'm going to do that is I'm going to hit I on my keyboard, which will inset them. And I'm doing this so that I can offset them away from the border. So I'm going to select the edges along that side, and I'll scale them along the x-axis. And then I will extrude them inward. Make these nice little gaps. There we go. And also, while I'm thinking about it, I'm going to delete all of the polygons along the outside. Now, if I were making this model for animation as opposed to a game, I would probably bevel these edges, just because that looks a little bit nicer. However, that does create a lot of polygons that we don't need, so I am not going to do that. Next thing I'll do with this model is I'm going to work on the lock. So the first thing I'll do is extrude this outward, and then I'll scale it down. And that may actually be it as far as the hexagonal portion of the lock is actually concerned. In fact, I think I may leave it at that. All the other detail I'll add into the normal map. So now we have this, and the topology is looking pretty good, but there's a lot of polygons here that we don't need. We don't need a lot of this middle edge in order to convey the fact that this is flat. So in order to optimize our object for a game engine, I'm going to be getting rid of several of these polygons. So right now the triangle count of this object is 204. Let's see if we can't lower that down a substantial amount. So the key to removing triangles is merging together vertices that do not contribute to the silhouette. What I mean by that is that if we were to look at this from the side, we see that it's completely flat. We only need so many polygons in order to convey that. Specifically, we don't need these edges right here to convey that this is meant to be a flat surface. So we can merge those with the vertices above them. The way I'll do that is I'll change my selection mode to vertex. I'll turn on snapping, and then I'm also going to turn on something else. Down here in the mesh menu, we have something called auto merge editing. What that does is that whenever you have snapping enabled and two vertices get very close together, close enough that they snap, it'll automatically merge the two vertices together. So I can just select this vertex, hit G to grab it, move it up to that vertex above it, click, and then they're merged. So what's important to take away here is that there are 2 phases to modeling something like this. There's the phase where we create the shape and the form, and then we optimize it. And the reason why we can even optimize this model in this way is because it will not deform or even animate for that matter. This is a static environment asset. Since it doesn't need to deform, we don't need any vertices or edge loops dedicated to capturing that deformation. Okay, so this is a start, but there are a couple problems here. I don't like how thin these polygons are. They're still full polygons, but they're very, very thin. So I'll merge these over. That'll fix it a little bit, but that won't fix the ones here in the middle. So what I can do is I can use our knife tool again, and I can cut across that edge in the middle, like so. And then I can delete these edges right here. Again, we need to dissolve the edges, not delete them. And then there's one other step. If you do that, dissolve edges, you also need to change your selection mode to vertex, and you'll see we still have those vertices in the middle here. So we need to dissolve those as well. Now this actually gives us the exact same triangle count that we had earlier, but the spacing of the polygons is a little cleaner. Now I know I may have just given a big spiel about how the topology wasn't really important since it wasn't going to be deformed, but having really long and narrow polygons like that can actually lead to some shading artifacts depending on what render engine you're bringing it into. Whoops. So I just like to try and keep those to a minimum. And as you see, we reduce the triangle count of this from 204 to just 140. And in object mode, it looks exactly the same. Excellent. To finish this off, I'm just going to mirror it to the other side. And then I'll mirror it, but I don't want to mirror it across the x-axis. As you see the direction of the green arrow, I need to mirror this across the y-axis. Excellent. Our container is really coming along. Now let's focus on these vertical bars. I'm not going to worry about the handles here so much. I might throw those in a little bit, but I'm not going to do that immediately. So if I take another look at those, as you see, it looks like they're connected at 4 points. The top, the bottom, and then these bracing plates just shy of the top and bottom. The way we're going to do this is we're only going to make one, and then we'll duplicate it 3 times. So the first thing I'll add is I'm going to add a cylinder, and this one's only going to be 4 sides. And the reason I can get away with it being that low resolution is that it's going to be very, very small. So the first thing I'll do right here is actually the very first thing I'm going to do is I'm going to cut it in half. So I'll cut it in half, and then I'll select all the polygons on the bottom and delete those, and then I will mirror it across the z-axis.